Good morning, good afternoon. Welcome to the World Electrolysis North America pre-event interview. We're here with Joshua Young, Senior Vice President of Sales and Marketing at Virginia Transformer Corporation. Hi, Joshua.
Hi, nice to meet you through Zoom.
So just to start off, Joshua, would you be okay just giving an introduction to yourself, Virginia Transformer, and some of the work you do along the value chain?
Absolutely. Yeah, my name is Joshua Yun, Senior Vice President of Sales and Marketing for Virginia Transformer Corporation. I've been with the company for a little over 3.5 years, but I've been in the transformer industry for about 25 years. I am an electrical engineer. Started my career as an engineer designing and then commissioning large electrical infrastructures for about 8 years. So combined, I've been in the electrical industry for about 33 years. As far as the Virginia Transformer concerned, we call it VTCs here, just to be short. VTC was originally established in 1971. So we're actually 52 years old company. So we are very unique in nature that we only do transformer. I mean, that's what we do, right? All the other company, they do switch gears and it's all these other product, but we are the specialist in the industry. So because we've been doing transformer designing and then building and then commissioning transformer for 52 years, we are one of the I guess oldest and also the most experienced manufacturer supplier in North America. Since the formation in 1971, the company has acquired a number of companies, other transformer companies, expanding our capacity, as well as and then we actually built two plants in Mexico from ground up. So and then on top of that, we've been expanding existing plant as well. So right now, currently, we have 6 manufacturing plants in the U.S. and Mexico with the combined total production capacity of 69,000 MVA, which makes our company the largest U.S.-owned transformer company in North America. So just to put that in perspective, we pretty much, if it is transformer, anything from 500 kVA, pan mount, substation, or dry type, all the way up to 500 MVA, basically 345 kV class transformers that we design and manufacture. So again, we play in the North American market. We probably only 2 or 3% of our overall business is outside the U.S. So we're here. We've been here for many decades, and then we're here to serve pretty much all market segments. When I say all, utility, renewable, commercial, industrial, data centers, oil and gas, and then I can list every market there is in North America. But basically, we have a large share in pretty much all market segments. So in overall, roughly our guess is, but we anywhere from 8 to 10% of all the transformer right now that's installed and that's working in the U.S. Electrical grid are from our company. So that's how we've been, our install base is how large our install base is, and with a very almost no field failure issues in the history. So again, considering us, that makes us one of the most reliable company in North America. So that's just a brief description of our company, hopefully that was enough to provide just a glimpse of who we are.
Yeah, definitely so. And it's interesting to learn about all the different industries that you're involved in. I suppose, obviously, with the focus on the hydrogen boom that's come lately, obviously you've worked with power electronics and different renewables sort of over the trends that have emerged over the past decade or so. But particularly with hydrogen, what are the challenges you see in that renewable hydrogen market?
Okay, great question. I guess we need to start with the current market situation here. During COVID has been hard for everybody, right? So during COVID, many of the major infrastructure upgrade or new projects, they're all put on hold to various reasons. When the COVID pandemic subsided, what happened is that all the projects got released all at once. It's almost like a tsunami. It's like, I call it perfect storm. So we've seen this from pretty much all market segments, utility, all the renewable, solar, wind, and then battery energy storage project came online. Oil and gas with the Russian war in Ukraine, that created huge demand for LNGs that export to Europe. So all the LNG project came online. And then and on top of that, data center is just like there's gangbuster, like there's no tomorrow. I mean, there's so much data that's being captured right now, being stored and processed. So data center. So what he did is that he basically this tremendous amount of demand was far exceeding available capacity, production capacity that was available in North America. So in other words, the only way to do that was pretty much every plant, doesn't matter who they are, every transformer manufacturer that's basically supporting North America market, plants got full. Okay, so we have 6 plants. So depending on the size and the complexity, small little pad mount transformer, for example, we're out to 1 year. 45, about 50 weeks. So close to 1 year lead time at this point, pure backlog. So if you give us an order today, we have to wait 1 year for us to get started. As the size goes up, it goes up to 2 years. And the large part transformers now, we are right now, available slot is about 2 years out. Okay, maybe 2.5 years out, depending on the size. Okay, so this is right now pretty much with every transformer manufacturers. So that creates a huge bottleneck. Okay, think about you have to wait 2 years to get a large part transformer for a new plant that you're planning. But if you're not aware of the situation, okay, and then you already plan ahead and with your schedule thinking you can get the transformer within a year, then you later found out that's not the case, it's going to create a huge impact, huge payback with your overall schedule. So that's going to be the biggest the impact or the kind of a risk right now that people, hydrogen, especially developer, would face given to current market conditions. Okay. Another thing right now that makes it harder is the transformer that's required in the hydrogen market are quite unique in sense of in terms of designs. Okay, because the transformer that's especially inside the plant. Okay, that right now because electrolysis requires a DC power, and the DC power is provided by rectifiers. And the rectifier requires rectifier duty transformers. So they're highly specialized, highly customized units of design, okay, that is specifically designed to mitigate, reduce harmonics. So many of these are what we consider as multi-winding. Instead of a one high voltage and low voltage, many of these would have one high voltage and then maybe 5 or 6 low voltage windings. So think of it as 2 or 3 or potentially 4 transformer guts inside of one tank. So it's very, very complex, and there's only a handful of us in North America who has capability even tackling such a design. But this is absolutely needed and critical. You cannot do electrolysis without these equipment, rectifier duty transformer and rectifier. Okay, so again, that makes it that creates huge risk for overall planning and then for the hydrogen projects. And so yeah, so that's basically what's in a situation. And also, because now if it is a green, for example, green hydrogen, that means that power feeding that particular production plant has to come from renewable. Okay, so that means that renewable power has to be generated, from either solar farm or wind farm or maybe with a combination of battery energy storage systems. Okay, again, that requires tremendous number of transformers to step up the voltage, either large power as well as small pan mounts. Okay, so and then and in front of every hydrogen production plant, it requires its own part transformer, as well as the number of these what we mentioned rectifier duty transformers. So just giving you an idea, typical 100 megawatt plant would require anywhere from 2 to 4 large power transformer that has lead time of about 2 to 3 years, and then require probably anywhere from 50 to 80, okay, is medium voltage, highly specialized medium voltage transformer that has a lead time of anywhere from a year to year and a half. Okay, so that's the challenge. But ultimately, the biggest risk right now is the power availability. Okay, transformer do not generate power. It's just all it does is transformer either step down or step up. That's all they do. But the power obviously has to be generated and transmitted by the local utilities. And then local utility, I don't know if you know this, but they're also struggling to try to get a hold of transformers, because a lot of these transformers that are right now in service are at the end of life. So what they mean by it is they've been installed in 70s and 80s. So many of them, average life right now is probably ages, 50, 60 years old. Okay, so they just don't know when these transformers are going to fail. So they're kind of also desperately trying to upgrade and then replace this transformer as fast as they can. So again, pretty much these are the situation that we're facing. That will be basically that would definitely have a huge impact on how quickly we can grow a hydrogen industry as a whole.
Given the challenge, the complexities around the size of the transformers, the technical expertise required to develop them specifically for electrolysis, the aging of transformers, where does Virginia Transformer Corporation fit in there? What solutions can you offer to help ease the burden on the market?
There are many, I guess, electrical equipment that goes into, I guess, the hydrogen plant. Okay, so and every single one of these pieces are very important. Okay, but at the same time, what we often do is we take it for granted on power. We every day, come home, turn the switch on. We do not expect there's power's not going to be there. Power, we just assume power is going to be available. Same thing. A lot of cases that we believe power is going to be available and it's going to be stable and then it's going to be reliable. Okay, so in most part, yes. But again, all the power that's flowing through that new plant must go through a number of transformers. So transformers usually don't fail, because as long as you design properly, and then per the specification, and then it's not being misused. So pretty much very, very robust, very, very reliable products. But at the same time, transformers do fail time to time for various reasons. Okay. So think about the implication. Large power transformer, 150 MVA transformer fitting a new plant. Okay, that's basically 100% power is flowing through it. That transformer was built specifically for that plant. So there's one of its kind. There isn't anything that you can just buy from off the shelf. It took 1.5 years, 2 years to build that transformer. And one reason or the other, 2 years later, that transformer had a failure. What happened is just lost power to the entire plant. Okay, so now the question is, do you wait 2 years for a replacement unit? How quickly can you get that? Okay, so that's going to be a challenge. And also along the, inside the plant, obviously you have smaller medium voltage transformer throughout the plant, and a 1 or 2 for each of these electrolyzers. Okay, so if one of those fails, it's not as detrimental because you have others that are still operational. But again, you just lost huge revenue because transformer has failed. So what it boils down to is transformers are not all the same. Transformer has to be reliable. So reliability must start with robust design. So, and then robust design could only come from experience. How long you've been building those complex, customized design. Okay, so you can't really select a supplier, manufacturer that's just getting into the business. Okay, just too much risk. So what we bring to the table here is, Virginia Transformer, again, we've been in business for 5 decades. And then we've been building this complex rectifier duty transformer and this power transformer, generator step up, auto transformer. Where is this type of transformer that's needed for hydrogen industry for many, many years? Okay, and then we have the expertise or technical prowess to ensure the designs are robust. At the same time, we have been, improving our operation excellence over the years so that we know how to build transformer. Again, 8 to 10% of all transformer right now in U.S. electrical infrastructure grid is ours, and they've been operation for last 40 years, 50 years. Okay, so from a record perspective, we have track record that not only robust design, but at the same time, from operation production perspective, we build robust, reliable transformers. The other thing that is very, very important that I always recommend anybody coming into this market here is because they're so unique, okay, and then especially large power transformers, okay, and then even the small or medium voltage one, you need to be able to have after-sale service, okay, so warranty. If you buy from overseas, from Europe or Asia or some other countries, and and they got a transformer here, okay, something happens, then what happens? Then what do you do? Do you wait for 12 hours until they wake up? What can they possibly do? They're not going to fly people. Even if they fly people in, they don't have the equipment. So they're in a mercy of available contractor in the US. But the contractors are not the expert. They're a little bit dangerous enough to kind of do a quick repairs and stuff like that. But when it comes inside the transformer, they're clueless. So this is where also, one of the strengths is that we have one of the largest field service crew and team here in North America. So, and then we can deploy pretty much our team within maybe 24-hour, worst case scenario, 48-hour to site with our equipment. And then because of our crew are originally from the factory building transformers, so they're the expert when it comes to knowledge and experience is concerned. So that's another thing that we bring to the table. Also, logistics. Okay, shipping transformer, we don't really, again, think too much of it. How hard could it be to ship a transformer? You'd be surprised. Shipping a 150 MVA transformer requires tremendous amount of coordination. Okay, so if it travels on a truck, for example, okay, it usually takes about a week, dedicated team, to come up with routing. We call it routing. Okay, just to figure out which route, which highway, which road, okay, that this truck can go without hitting a bridge. Because remember, there are bridges and the bridge has a height restriction and weight. So all that needs to be taken care of. And depending on the size, these are wide loads. So sometimes we cannot travel during the day, so they require police escort. So it may go through 50 different police jurisdictions before we go from plant to the final destination. Okay, so we have to wait for one jurisdiction and second jurisdiction to come. So man, it may take 3 weeks to get there. Okay, but this is what we do. So our team is dedicated to handle, and then we also ship it. It's large enough. We ship it through railroad. Actually, railroad come into the plant, and we actually load it onto the rail cart. That's how big the transformer gets. So it's very difficult challenge to do, and you ship it across the ocean from overseas. Okay, I'm not saying it cannot be done, but again, from a coordination perspective, from a service perspective, this is something that you really want to avoid. You want to work with partner with somebody who's been in North America, serving U.S. and Canada market for many years with experience, proven record of not only the technology, okay, technical expertise, but also operational, also the customer service and the field service and logistics. These are all the things that kind of comes into play when it comes to transformer. Purchasing a transformer that is most reliable to provide, making sure that the power is flowing through the plant, supplying a reliable power going through the hydrogen plant. Okay, so that's going to be my advice, my suggestion to anybody who's coming into the hydrogen market. Okay, first, make sure that your planning cycle, okay, is taking into consideration of the current lead time of the transformer suppliers. Okay, fortunately, what we do, probably the biggest, the strength that we bring to the table here is we have the shortest lead time in the industry at this point. Okay, and I'm proud to say that in confidence that compared to any and all competitors, supplier, both domestically as well as overseas, we offer the shortest lead time. Okay, so well, how we could do that? Because we have the largest capacity, and also we have adequate labor force to produce transformer at various different locations, and then we have the technical expertise. Okay, 30,000 what we consider reference design, done design that we have built, commissioned, and operation to pick from. Okay, also because we're quite not 100% out of the wood on supply chain issues, so we are also maintaining currently $20 million worth of long lead critical item in our inventory, and then they kind of stashed away, stored at various different locations. But again, combination of all of this is allowing us to offer the shortest lead time for transformer, very sized transformer in our industry.
That's been through most of my questions, but I want to thank you again for taking the time to speak and to answer some of these interview questions.